Well, good afternoon, everyone. We'll get started again. Hope everyone was able to get a break, grab some lunch, and come back energized. I know we left here energized. It was a really great morning with some fantastic discussion, individual panel talks, and then the panel discussion afterwards. And I know we're in for a treat again this afternoon. And so thank you for returning. I hope you will stay throughout the afternoon and again enjoy the panel discussion and then join us for a social hour afterwards in the Candle Factory where we continue these conversations. Again, our thanks from the NHA to the Park Service, to the Osceola Foundation, to the Nantucket Community Foundation's Remain Nantucket Fund, and again, my pleasure to welcome up here Marty Hilton.
Hear me? Okay, there it goes. I just wanted to say, on behalf of the National Park Service, I wanted to thank Rohit and ICCROM. This was an international, national, and local partnership with the Nantucket Historical Association. In addition to Osceola and the Remain Nantucket Fund from the Community Foundation, I also wanted to acknowledge the Brownlee family and Michelle Kolb for the donation of property, so we didn't have to sleep in the streets of Nantucket while we were here. So, without further ado, you should have a packet. If you don't, we can get you one with the bios. We're not going to take time to introduce it. Their bios are so extensive that we would spend the afternoon. So we're just going to let them roll one right after another. Again, we do hope you stay. There will be a reception in the Candle Factory right about 5 o'clock. So with that, our first speaker, Frank Matero.
All right. Okay, let's see. Good, okay. Thank you, Marty, and thanks to everyone for bringing us together. I always gauge the success of a conference or a gathering based on how many people I don't know. So I think this has been highly successful, and it's been a real treat for me, especially to meet our European colleagues. So this morning you heard from the European team. You're going to hear from the American team this afternoon. I think we're going to get a bit more in depth into some possible solutions. We heard about the problems this morning, and Robin gave us a bridge to some possible upbeat and optimistic things to think about. I'm going to hopefully continue that. The presentation I want to make today is in two parts. And I say that so you don't think that the whole half hour will be filled with graphs and charts, because that would be horrific. What I am going to do, though, is I think to set the stage, it's quite important for me to share some very recent work that we've been doing at the University of Pennsylvania on climate change and built heritage, what we know in terms of the literature review. And I'll get into this a bit more. And this, the second part will then present briefly a case study, which I've already shared with our colleagues earlier this week, to really look at the ground truthing. I mean, all the climate data is critical, of course, and a lot of it is based on modeling. But I firmly believe that there is actually a lot of ground-based evidence that we can learn from by looking at sites in a much more critical way, and in a sense, learning by going backwards and then bringing that forward. So I want to share some of that, and the good news is we won't really be talking about sea level rise at all, but something that's happening in the western part of the country, which is desertification, drought, and the implications of that. I think it's often thought that that's, for sites, that might not be a bad thing, but in fact, it's quite the opposite. With that, I'll give you some time to look at this, and I will I'll proceed. So the message I hope to leave with you is that the situation is far worse than we imagine. Not just in terms of the climate crisis, that's certainly bad enough, but in our lack of preparedness in terms of the information we still do not have and need now to make informed decisions about the most basic safeguarding of built cultural heritage. We don't know what we don't know, and that's, of course, the worst place to be, certainly as an academic. Though studying the climate crises speak in terms of anticipatory science and management, meaning we have very limited data upon which to develop effective short to near-term responses to mitigate degradation and damage driven by global warming and all of its cascading consequences. And we certainly heard that today. The answer to this is what to do to remedy this. What we academics tend to do to solve a problem is research. To quote Albert Einstein, if we knew what we were doing, we wouldn't call it research. So in this case, we reviewed the past 30 years of published literature on climate change and built heritage to identify what questions scholars and practitioners are asking, interpret those ideas, detect any shortcomings, and recognize opportunities. Those opportunities then create research agendas to generate methods and data we need to make better decisions with. So in 2007, World Monuments Fund actually held or presented some of the first work on cultural heritage and climate change in the US, although their stretch was global, in a panel discussion at the George Wright Society. And it's, of course, been progressing ever since, as I'll show you. Then in 2017, a bibliography was produced that looked at the current state of knowledge with 124 citations. And the findings were basically the geographic scope is limited. There's little information on actual methods of execution of proposed planning models, and most of the research was coming from Europe. And as we heard this morning, no surprise. I mean, they have been banding together as the European Union to look at many of these questions. So again, not too many of these, but I just want to show you our process. So it's not that easy to research something where the keywords are not even identified officially. So we began, this is again, I had a team of graduate students, so we could test a lot of things, some of which went nowhere. But we began with a keyword search. We looked at built heritage and climate change. That was the big domain. Then we looked at built heritage and climate change and disaster or hazard, because those are popular common words in the problem. Then we looked at built heritage, climate change, mitigation or adaptation or resilience or vulnerability. These are Boolean searches that help us to really test the waters as to what is out there in terms of what individual camps, whether they're scientists or historians or economists or logic theorists, what they're writing about or how they're writing about it. We put all of that search was done through these 4 search engines, familiar to some perhaps, and from that we created a shared file database. And from that we then put the material into a Mendeley repository. Mendeley is a bibliographic software that helps you manage the information. Here's what's important, I think, to some of the folks in the room involved with convening us this week. We realized that a great deal of the literature was not material specific, meaning it didn't drill down into the details of just how our historic resources are responding based on their construction or their materials, right? And so we felt that was really important path to pursue. So of the 445 citations that we found, 279 addressed in some detail the following construction and material systems: brick masonry, stone masonry, wood or timber, adobe or earth, plasters and mortars, and concrete. Concrete, we actually dropped out because there were almost no citations. That's a problem, actually. That's going to be a problem for sure. It is a problem. Okay, let me go ahead. And so this was the master key list which we created, and from that, we reduced it down to these final keyword lists. And again, I'm not going to go through these, but you can take a quick glance at these. And these, we believe, they occurred the most often, and they produced the most results. So this would be, if anyone asks me, this would be the working list of keywords I would use going forward in doing any kind of research going forward. This is the kind of quick table that Mendeley produced based on author, title, year, where it was published, any details about that. And this also had PDFs of these articles linked to it. So a really powerful tool to get your hands on information to whatever question one might want to ask. And from that, we created a database in Excel that had author, title, date, publication, theme. In this case, it could be brick, masonry, etc. What continent the site, if it was site-specific, was on, or the research was done. The country, same thing, city, site. Associated risk or hazard. Very often, this material is generated based on a specific threat, like sea level rise, or desertification, or drought. If documentation was a theme, very often that is the response, is to document. If monitoring had been done, very important to us, as you'll see later, and if any interventions were done, and then what were the keywords that were associated with that article. From Mendeley, we produced any number of things. This is still, I mean, you're the first audience actually to hear this. I have not presented this yet. This was a good opportunity to pull it together. But certain things can come out of this, like a timeline, not unlike what Robin showed, a wonderful timeline of the introduction of going from natural to artificial materials over time and what it's done to society. This is just a quick snapshot of the articles that we collected by material across a timeline. We began collecting, we went back to 1990, and you can see, no surprise, there's a correlation with the COP meetings and the IPCC meetings. So things started to rev up by 1999, and you see they begin to really get some steam in 2006. And you'll notice on this, and this leads me to the second part of my talk, you'll see that the material that really experiences a great interest and in at least two peaks, but always in a rising trend, is earthen architecture. And that should be obvious, maybe not. I suspect you don't have too many earthen buildings here on Nantucket, although you probably have earthen mortars and don't know it. Is the fact that it represents in an extreme the most fragile material, particularly to the major hazard, which is precipitation or intense precipitation events. So as my little image there indicates, earthen buildings really are the canary in the climate change coal mine. They are the things that we will actually be able to witness in our own lifetime, significant changes that we did not witness before. And just seen another way, again, the yellow is the earthen architecture. You can, of course, see a general rise over time in interest in the subject. That's good news. But you can see there's a disparity between who is working on what and the amount of information that exists for each building material and building system. And here in a pie chart and histogram, you can see for each of these materials the relationship between general writing about those materials and more specific, the kinds of things we were looking for in terms of comparative data. Is there actually quantitative data as opposed to just talking about a problem? And here by hazard. Again, all different ways we can look at the data. And you can see that, again, precipitation for each category is a big factor in terms of attention to a hazard. And then you see earth has the most citations, seconded by masonry. And here by location, again, no surprise, Europe has been leading the charge on these kinds of studies. I suspect largely because of the collaboration across countries and the ability to fund some of the projects, of the many projects that get put forth, more than we do here in North America, certainly. It's interesting to see out of Asia comes the most research on earthen architecture. That's encouraging because it certainly is a prolific building material in that continent. And here, just another way of showing that in terms of location infographics. Monitoring is a really important aspect of this. It is where we have to start. We've We've not done a very good job of this in the past, but monitoring for climate change, monitoring for effects we're not even sure how to measure or what the tolerances will be is a really important thing to do now. And we wanted to know what others had done so we could prepare ourselves for the case study I'm going to show you. So the takeaways are it's worse than you think. Again, in the two ways I've mentioned, not only is the climate crisis quite an issue, but we simply don't have the information we need to make informed decisions to actually act on the ground. Second thing is, climate threats are outpacing our understanding of damage to built heritage. Materials-based vulnerabilities are understudied and uneven. And long-term monitoring is lacking and the methods are uncoordinated. So that's the bad news. Now let me suggest some possible hopes for how we might proceed. And again, really what I am talking about here is a methodology. Whether or not you're interested in 19th century earthen forts, it's really not the point, or in the American Southwest. The point is we have some possible ways to proceed that could begin to give us some very interesting information about how to go forward on collecting the data we need to ultimately intervene in ways that are preventive as opposed to reactive. So for those of you who've not been to the Great American Southwest, it's of course fully representative of the entire span of human occupation of the continent, and great examples of every period extant as cultural heritage. There's also been an equally, or not equally, but an extremely long period of conservation to these sites that go back to the earliest efforts in this country, beginning in the 1880s at Casa Grande on the upper right. Some of you may be familiar with the Great Shelter. A superb example of preventive conservation, right? Put a shelter over it. It solves a lot of problems. But over the last decade, increasing catastrophic failures have been occurring at sites across the Southwest, usually related to extreme weather events. Climatologists know the region is going to drought and that extreme weather events are more prevalent. However, the question is, can we better understand differential vulnerability of a site through a set of pre-existing conditions, knowing full well that the climate indeed is changing and cultural resources response will be different. And these are just some examples of some of the unexpected or unpredicted catastrophic damage that occurred in the last few years. But our lack of preparedness in terms of the information we still do not have and need now to make informed decisions about the most basic safeguarding of built cultural heritage is holding us back, resulting in the kinds of catastrophic failure you see here on the lower left, which should have been predictable had we known what to look for or measure. And I show you an example of one possible solution would be, as is being done now, to look at certain kinds of simulations and modeling with new softwares that will allow us to do things like computational fluid analysis to look at things like wind load, something we normally don't consider, but given the geometry of some of these spaces, we actually see that has a huge effect on what walls will stand and what walls will fall based on a intense weather event. To do this, we'll need to develop better evidence-based risk modeling and vulnerability frameworks to be able to explain the above scenario as to why certain walls stand after 120 years while some are fragments and others are simply gone, reading left to right. So why? How do we explain this? So our answer, working in partnership with the National Park Service and the Vanishing Treasures Program, was to develop some ground-based, evidence-based ground truthing that could begin to learn from the site as a primary form of evidence to what the site has been, how it has been performing over the past 100, 150 years, depending on when you want to start counting, from construction or from abandonment, that might give us some clues as to what is going on, not just on the material alone, not just on the architectural systems, but actually on the entire microclimate, microenvironmental context. And the factors we considered were material composition, the construction, the orientation of the buildings, their exposure, whether they were protected or not, previous and current treatments, cyclical maintenance, and visitor impact. Now, I would have to say this is relatively, this is far simpler in a building that's a ruin than an active building that's being used every day in different ways, with heating and ventilation and other systems in. So at least we're starting with something that's manageable, but also unprotected. And I would suggest that you think about this the way you think about your own bodies, hopefully, when you visit your primary care physician and they will ask you the questions, well, what are you made of? How are you constructed? What's your family history? What's your exposure? Do you smoke? Do you drink? Is there cancer in your family? Do you exercise every day? And what's your visitor impact? Again, I don't know what that quite would mean in a biological context, but you can use your imagination. So this is the site, a sublime site coming from New York City. I find this completely alien. It could be Mars in my world. Fort Union. And to me, this is more than an historic military site associated with national policies of manifest destiny, colonial expansion, and the taming of the West. These are all things the Park Service uses this site to interpret. To me, it's a laboratory of incredible possibilities to study the many possible variables that determine vulnerability. And that's a big one for us. For a site like this, it's a large Adobe test site to examine the many plausible factors influencing the performance of Adobe construction. And what's also quite excellent here is there's over a 50-year history of conservation documentation that you see on the right. Here's a before and an after in the 1960s. We don't often have that kind of documentation. So one of conservation's fundamental questions, whether you're working on an object in a museum or on an outdoor site, is how do we understand change over time? Now the scales here, of course, are different. And in a minute, I'll be talking about the micro, the meso, and the macro. But how do we explain change in a more nuanced way, not just before and after, but where did it happen? When did it happen? And how did it happen? This is the way we can tease apart correlation from causation. And as this image suggests, 1959 on the top, 2016 on the bottom, how did we get there? What happened? Was it episodic or was it catastrophic? Of course, more photos would help. So again, thinking about the problem in terms of these three scales. We know a lot at the micro scales. Scientists here in the room have been studying the problem of earthen materials at the micro level for quite a long time. We understand quite a bit about clay mineralogy, about grain size distribution and its effects on soil performance as a building material. We understand about the interaction of water and clay minerals. But when you take those phenomena and you put them in the context of an environment that has many more variables, it's a very different situation at the architectural level and then, of course, at the climate level or the contextual level. And so I teach in a design school. We like to visualize things. So we wanted to take this change over time that existed in qualitative photographs, that existed in some numbers, but not a great deal. We wanted to visualize it. And so here you just see an example to show the site stewards just what has been going on. So since abandonment, started in 1851, the third fort constructed in 1871, abandoned in 1891. From 1891 to today, there are 5,000 linear feet of adobe wall, 50,000 square feet of surface. That represents 56% loss, 44% remaining since construction when these were whole buildings. And you see the current elevation of one of the buildings at the top, and then the red lines indicate the building when it was constructed and functioning. So we're visualizing change, and we're putting some numbers to it. We also wanted to find a way, again, to bring all this data together. Yes, we did, in fact, do it in, for those of you who know geographic information systems, in levels and layers as a platform. But again, to take this out into the field or to show it to managers who may not know these softwares, how can you visualize this wall by wall, building by building, to show the quantification of change? And I'm not going to analyze this, but this is a floor plan of one of the buildings showing that, if you want to read this, the denser the wall, the higher it's standing. And then there are pie charts and histograms of the percentage of walls surviving for each side, whether it's north, south, east, west. And what this is suggesting is exposure and orientation indeed have a great deal to do with what's surviving based on prevailing winds, prevailing storms. Again, trying to bring phenomena together and working backwards explain why what is there and what might have caused that. So let me go through the various components or data sets, if you will, of what we chose to look at. So again, use the medical analogy if you like. Legacy data. You know, what processes created the site? Excavation, stabilization in our case. We're not going back to the original construction. And then what about the treatments from 1954 to 1960? Every chemical known to man was thrown at this building. I mean, really, it's remarkable. Polymer scientists would have a field day here. And then 1981, there was a complete rejection of that, and the Park Service began using non-amended, only earth and natural materials to stabilize. And then these are just some of the treatments that were done, and these are the notebooks, and fortunately, some photographs. This is really great data to have, and we have to learn to use it better. It's not historical as in the past. It actually is very valid and relevant to interpreting what we see today. We then brought in additional forms of examination and investigation. We thought about how moisture might move through the wall. We did a whole series of tests to look at various monitoring systems that might be used to do that. Even something as simple as one standing adobe wall can have moisture moving in all directions at different times of the day. And again, the context can really affect the things you're measuring. And then we looked at the localized weather through installing a weather station right at the site. We also did structural analysis, knowing that the out-of-plane behavior of these walls was critical, because that is what would determine here today, gone tomorrow scenario of total collapse. Why were these leaning in the ways they were? There were all kinds of deformations, tilted, deformed, racked, and it all depended on the context, not the composition and not really the construction. So it was external factors. As I mentioned, in terms of environmental diagnostics, we developed a monitoring protocol based on a localized weather station. These are the kinds of data we collected, not the kinds that were being collected by necessarily the park in terms of everyday weather that they were recording, the kind of data you might get at an airport, for example. I don't have really time to go into these, but this is the kind of data that we picked up in terms of wind speed and direction. This, we realized, was very important for the resulting geometries and weathering patterns that we were seeing. And then again, putting this into a computer modeling and simulation, using computational fluid dynamics, we were able to actually see the effects that the model suggested would be in place with wind and also thermal gain. And we then looked at that. Here's another example of how the geometry would affect that. And then this is really what I wanted to show you. We also paired this up with time-lapse cameras, which we set up. Thank you, GoPro, made it really possible. And this idea came from the people studying glaciers over 15 years ago. I remember standing at the Denver airport waiting for the tram, and there was a 3-minute video clip by National Geographic, who'd funded the first examples of using time-lapse photography for climate change-related recession, and thinking, well, how is an adobe wall not like a glacier? Right? So we set these things up, and what these show you, of course, is unless you were standing there 24/7, of course, the entire winter, which I wouldn't suggest, we could see where snow collected and where it didn't, and it was not intuitive. It was counterintuitive, as this would suggest. And this can be explained by the simulations that we ran with the geometries of the wall. So this was a nice correlation of the simulation and the real live field event. So taking the macro, the meso, and the micro data, we were able to tie it all together and develop a monitoring network that we are suggesting other parks in the region might consider doing, and in fact network those data sets. And so qualitative data mining, snow deposition, surface moisture patterns, things like animals, vegetation that come and go, and then quantitative snow depth, soil bridging, which happens when our treatments fail and they begin to connect the walls to the ground in ways we really don't want, wall deformation, crack formation. These are all things that we have identified going forward as things you'd want to measure. And all of this is to say, it all leads to a priority schedule of resources based on their walls, if you like, based on their vulnerability. Remember, vulnerability is a function of sensitivity, in this case, sensitivity to moisture, in the case of an earthen wall, divided by a condition at any given time. All of us here in this room have different conditions, so do the walls, times exposure. Some of you are sitting closer to the door than others. So these are the factors that will make or break the predictability, the current state and predictability of a wall. That may seem very simple. It does to me now, but I'll tell you, at the time we started, we had no idea what was more important in terms of considering the factors. And so here you just see some of the evidence-based hierarchy of what we might define as vulnerability, okay, in this particular case. So, the whole point of this, why we're doing this, and here's a photo from 2015. This is my last image. I assume that's my subtle. Before we completely adopt a resist, accept, direct management strategy, we have to make better predictions about future failure. Research on cultural heritage and risk from climate change entered the research agendas in 2003, and I think you've heard this morning. We're not as far along as we should be. And the data certainly, the literature search certainly confirms that. So while we have much data on climate change itself, thanks to climatologists, we have very little evidence-based quantitative data on what is happening to our cultural resources and what that looks like over time, especially at the meso or building level. So considering all site vulnerabilities from intrinsic factors such as materials and construction, age and maintenance, to larger aspects of climate and policy, allows us to fashion better responses, going even beyond the current, not so new anymore paradigm of preventive conservation, and in post-Katrina language, going from resilience to adaptation, where we need to embrace a different approach rather than improving existing solutions. So, thank you for your time. Just in closing, I'll say this is the first time I have lectured in a room full of Christmas trees and a whale skeleton. So I could check my box. So thank you.
Good afternoon, everyone. Wow, such a privilege to be here today and to have participated with colleagues in the meetings over the past 2 days. A special thank you to Marty and Glenn and Rohit for the invitation to participate. And thanks to the National Historical Association of Nantucket, National Park Service, and ICCROM for their support in hosting this meeting. My presentation today is entitled The Built Environment, How Can We Manage to Do More with Less? I will be discussing the work that was carried out over the past year, particularly focused on a case study example of a building envelope assessment combined with a monitoring program for the New York Library System in New York City. Looking closely at these buildings constructed throughout the 20th century, in many cases, there is evidence of poor energy efficiency and comfort within the spaces. And also there was the desire for this program to look at deferred maintenance of more traditional material challenges, and in some cases, poor energy use and thermal comfort issues for the users are the key reasons why the buildings for this century were needed to be effectively evaluated in order to meet climate goals for while respecting their history. However, as we've heard today from fellow colleagues during the morning session, the 21st century is facing ever-increasing challenges with regard to a changing climate. We are all too familiar with this image of major flooding in the World Heritage Center of Venice and the surrounding lagoon. Over recent decades, flooding in Venice has been exacerbated as a result of climate change and rising sea levels. The foundations of the city are also slowly sinking. Many experts say that the city could be completely underwater as early as 2100. However, this is very uncertain as the Mediterranean Sea is projected to rise over 4 feet by then due to greenhouse gases raising the temperature of the Earth's atmosphere. As has been discussed over the past couple days, we know that flooding causes irreparable damage, and we've discussed that over the past 2 days. In this case, after exceptional flooding in 2019, governmental agencies in charge of historic preservation at St. Mark's Basilica in Venice said that the building had aged close to 20 years in a single day. However, much closer to home in 2005, we witnessed the wake of Hurricane Katrina, in which the hurricane's 19-foot storm surge broke through the city's floodwalls and the levees. While the failure of New Orleans' flood protection system was blamed primarily on engineering flaws, it was also known that the foundations of the flood walls did not extend deep enough into the ground to support the force of the floodwater surge. In the slide here, Hurricane Delta hit New Orleans in 2020. Delta was the 10th named storm to make landfall in the United States, the 4th in Louisiana. It was a Category 2 hurricane. In August 2017, Hurricane Harvey was a devastating Category 4 hurricane that made landfall on Texas and Louisiana, causing catastrophic flooding and more than 100 deaths. Harvey is tied with 2005's Hurricane Katrina as the costliest tropical cyclone on record, inflicting over $125 billion in damage, primarily from catastrophic rainfall that triggered flooding in the Houston metropolitan area in southeast Texas. This made the storm the costliest natural disaster recorded in Texas at that time. Over the course of a 4-day period, many areas received more than 40 inches of rain as the system slowly made its way over eastern Texas and adjacent waters, causing unprecedented flooding and perhaps making it the wettest storm in U.S. history. And finally, Hurricane Sandy in November 2012 is considered to be the most destructive and strongest Atlantic hurricane, as well as the largest Atlantic hurricane on record, as measured by its area diameter with tropical storm force winds spanning 1,200 miles. The questions about recovery and whether we can build enough resiliency continue to mount as temperatures globally rise due to increasing carbon emissions. The largest emissions resulting in 2020 were from the building sectors, which account for approximately 38% of all energy-related CO2 emissions when adding building construction industry's emissions. It is well known that 1 in 10 people on the planet now live in a place that is officially declared a climate emergency. As a result of rising temperatures, the global sea level has risen about 8 or 9 inches over the past century. The rising water level is mostly due to a combination of meltwater from glaciers and ice sheets coupled with thermal expansion of seawaters as it warms. As we all know, our sea levels will continue to rise unless we slow atmospheric warming and drastically reduce our carbon emissions. Countries, governments, and cities must do their part so that we lower carbon emissions while increasing resiliency where possible in the face of sea level rise. Many cities, like New York City, have started to outline the major steps that must be taken to address climate change, as it is now critical that we cut carbon and that we adapt to the changed future climate. For example, in the wake of Hurricane Sandy and similar types of storm events, New York City is currently, New York City is currently pushing to achieve more resiliency by adopting guidelines to increase new design flood elevations and has adopted the freeboard back in 2010 to achieve this. In an effort to reduce carbon emissions, New York City and the state of New York has committed to achieving a 35% reduction in emission in the next 10 years. To achieve these goals, by 2025, New York City has also the need to complete efficiency improvements in every city-owned property that has significant energy use and install sources of on-site renewable power. New York State Energy Research and Development Authority, or NYSERDA, and the rest of the state government, in partnership with local and federal governments and the private sector, must meet these goals laid out by New York's landmark 2019 Climate Leadership and Community Protection Act. As an example, the new Local Law 97 now sets limits on greenhouse gas emissions of buildings with greater than 25,000 gross square feet beginning in 2024 to help the city reach 40% reduction in greenhouse gas emissions by 2030 and an 85% greenhouse gas emission reduction by 2050, both relative to 1990 levels. While the Local Law 97 is aimed at a larger building footprint, many owners with large asset portfolios are also considering measures to offset their carbon footprint and reduce energy consumption levels. So today, I'm going to focus on a case study example of a wider holistic assessment of individual properties across the city of New York, as included by the Central Library, other research libraries, and multiple branch libraries located across a portfolio of buildings for the New York Public Library. They're located in Upper and Lower Manhattan, the Bronx, and Staten Island. The project originally started with an aim to look at all of the historic structures, including the original historic Carnegie branches, as part of the New York Public Library system. But after much discussion with the library, their facilities, and their administration, the library decided to proceed with an evaluation of all of its branch assets. This was carried out in an effort to have a greater understanding of the total energy consumption in order to start to combat climate change and reduce greenhouse gas emissions across their portfolio of buildings. Here in this photo, you can see the range of building types and constructions over the past century. Building types range from brick masonry and stone masonry constructions to cavity wall constructions across the mid-century, and also more recent metal and glass curtain wall systems and stone cladding constructions. And so the program included a host of primary objectives, including inspections not only to evaluate exposed vulnerabilities, but also to visually assess components of the building envelope as part of deferred maintenance. This also included identification of different types of distress across many material types and systems, and to evaluate the potential measures for their repair and, in some cases, emergency mitigations. This information could ultimately be used to commence improvements for the building resiliency, promote energy efficiency, and to address issues of human comfort as part of each of the interiors of the library's structures. Program objectives not only included inventorying all the exposed vulnerabilities, but a concurrent program was put in place to monitor and measure thermal resistance of representative building wall types. This was an amazing opportunity for us to utilize different types of testing systems that could ultimately derive at the R-value evaluation for the wall types, to measure how a two-dimensional wall barrier system, such as a layer of insulation, windows, walls, or ceilings, could resist the conductive flow of heat. So in other words, the greater the resistance of the heat transfer, the greater the insulating effect and subsequent energy savings. This, compiled with understanding the needs of human comfort, could be utilized to make informed decisions about whether improvements should be needed or whether those resources could be put in locations that really needed it for the short term and the long term. We started by basically looking at the inventory and background database that the library had already established. We basically decided to build on the library's database system. So a central portal location for each branch location was accessed that provided background information and historical data. This provided a context for each of our building assessments. It included basic information about the original architect, the date of construction, the building typology, whether or not it was a landmark status, including its location and its where it resided in terms of different communities throughout New York City. We also attached a map of the representative branch locations across the island. The project included a GIS database that was linked up with the background information from the New York Public Library inventory data, so that the documentation, monitoring data, and reports information could be centralized and easily accessed by the project team. But as part of the document review system, we also took a deep dive into all the FEMA maps that could be utilized to overlay this information with locations where the library branch resided. And this was really to understand whether the buildings were subjected to potential flood zones in the future, and to also allocate resources to potentially doing more assessment work in below-grade structures. Overlapping this map information with the assessment program was key to being able to ascertain types of vulnerabilities and conditions that were unique to each location. So the approach for the assessment for carrying out the different levels of review on each project, including the review of documentation, included really looking at available construction documents, field reports, things that the library had collected over the years. A lot of it was scanned and made available to us, but it was in piecemeal fashion. I think what you can see here is the Kips Bay branch location. There were available repair documents, for example, that we could access, which were repaired as part of the proposed window replacement system. This was ironic because, in fact, we could look at these documents to really ascertain wall thicknesses and look at some of the dimensions for the different window types that were being analyzed. Available documentation also included roof assembly drawings and their installation. This, in some locations, included insulation thickness and membrane systems that could be evaluated and tested as part of the evaluation. We also, as I mentioned earlier, categorized visible signs of distress in order to make recommendations for further investigation or monitoring. This included recommendations for potential maintenance and short-term repairs and recommendations for long-term energy improvements. We also carried out high digital documentation as part of this project. We also included infrared surveys that were performed along the upper roofs, roof setbacks, wall assemblies. We used it basically as a tool to locate signs of moisture infiltration at both vertical and horizontal surfaces. In this photo here, you can see that the Harlan 124th Street Branch Library, this was a location that we utilized a pretty basic tool for digital documentation of the facade. It was a program called the GigaPan, and it allowed us to take a very, very high resolution photo, which I'm going to try to pull up here on the screen. So it's basically about 400 or 500 photos that have been stitched together to create one high quality photo. It's a very easy system to use, but what it allowed us to do was to really document the date and time of our inspections and assessment of the buildings. And it's a really great way to take a snapshot moment in time that you can then utilize as a baseline. You can see that the resolution here is quite, you can see the mortar joints and everything. It's pretty good. Zooming in too much here, but harness. Get the idea. Another large component of the building assessment program was to really look at thermal anomalies in the wall systems. Not only was this a qualitative assessment of the individual envelopes, but monitoring of interior temperatures was also recorded along with the exterior walls. Through the use of the heat flux sensors, we could monitor and test R values and U values of representative areas of windows and opaque wall assemblies. This is critical, I think, to understanding the thermal resistance of each building wall typology, and it really became useful so that we could understand these values across the building portfolio. Here you can see about half of the branch locations that were part of the assessment. The highlighted, the orange highlights are the locations where we carried out the wall monitoring at the specific locations. I think what's interesting about this is that when we were able to carry out the assessment monitoring on 14 locations, we basically had the representative wall types that then could be applied across the entire portfolios of buildings. This didn't give us a complete customized information data point for each branch location, but it was enough to give us an idea about how to make informed decisions going forward on which buildings were really energy deficient and where improvements could be made. So here you can just see a photo of the different building types that were included as part of that monitoring. You can see that some of them were mass masonry construction, stone construction, single and two-story transitional masonry buildings. We also had quite a few buildings that were constructed in the 60s and 70s that included brick cavity wall constructions and glass curtain wall and cladding constructions. And this is just the summary chart of those 14 locations and their R values. And what was interesting to note was that the solid masonry wall constructions, as most people could imagine, were the wall type systems that were most robust. So going back to looking at the original Carnegie locations, I don't think that many folks at the library really thought that their original historic structures were going to be the most robust systems. It actually ended up being that the buildings constructed during the 60s and 70s had almost reached the end of their lifespan because they were buildings that just had such poor building performances, which is what we could ascertain based on the study and the monitoring. So just to walk you through how we were able to carry out the R value monitoring procedure, it's pretty quick, and I think it'd be useful to do this. Basically, the first step was just that we had to identify the different wall areas through an infrared thermography assessment. This was done to really ascertain which areas we could apply the instrumentation to. So we carry this out on several different types of wall types. Here you can see 2 branch locations. We also were able to carry it across different stone cladding, more contemporary structures using the same IR scans. And then the next step was really to install the instrumentation based on what we found with the infrared thermography readings. You can see here that the thermocouple instrumentation was adhered to a wall on both the interior and corresponding exterior locations. The thermocouples basically measured the air temperature on both sides, and then we were able to also install a heat fluxer transducer that was installed to measure the heat rate at the surface. And then in the lower left corner there, you can see the data logger box that basically transmitted all of the data in real time to a central cloud system. As part of this installation of the instrumentation, there was also calibration of the equipment. We followed 2 standards to both carry out the measurement of the heat flux and temperature on the building surface components, as well as calibration of the heat flux transducers. And that was all really, basically, you can see it here, carried out on all the building type assemblies. And then the third step was really to take that data that was collected in the cloud and to really look for anomalies, things that weren't going correct. There were a lot of challenges on the site. Sometimes we would have inclement weather that would knock off some of the instrumentation, to have to go back out on site to replace it or to put it back in place. But I think for the most part, the standard requires that you collect data for at least 24 hours. In many instances, we collected it over the course of 5 days, and then we were able to import it into an Excel data sheet and process it pretty straightforward. The last step was really to determine what the R value was based on the collected data. So statistical computations were carried out using the summation technique that was outlined in the standard. As I mentioned, the challenges are that some of the limitations related to the installation of the equipment were basically due to the inclement weather, where we might have a snowstorm or very bad, winds that would knock the equipment off the wall. We also ran into a lot of site anomalies, variations in the construction typologies, fluctuation of temperatures. In many of those cases, if we ran into these problems, that would just extend the duration of the test itself. So we're continuing to use this application on other large inventory portfolios of buildings with clients. I think while this was a kind of a novel use of the standard in this particular application, we really feel that this could be used across many different types of structures, single-story and double-story, mostly for light to medium weight constructions. The other thing that would be helpful to do is to compare the findings that we were able to gather on this study with other types of buildings throughout New York City. And it would be, I think we're interested in trying to collect this information to make it available for people to use in terms of making informed decisions on projects going forward. And I think, you know, the use of the standard, in this case, the ASTM C1155, was limited to this type of construction, but we would like to see it extended to bigger size structures. So just some concluding remarks. I think it was very helpful to carry out this type of assessment with the buildings coupled with the monitoring because it allowed the client to really understand the full building system that we were dealing with. This is very important that we understand these assemblies and not just look at the materials in and of themselves. The other thing that's critical, and you've heard it, I think, at multiple times today, is that we can't just look at energy or carbon savings or even resiliency measures, but we need to look at the entire construction system, how buildings are put together so that we can understand how improvements can be implemented over the short-term and long-term needs. Finally, I think when we say sustaining the built environment, we really have to understand what this means. Can this be achieved effectively and economically using a balanced low carbon footprint? I think even though we have the assessment and monitoring tools as applied in conservation in the past, we need to adopt them to understanding the current problems that we see today. These tools can allow us to make more informed decisions. And I think question the tools that were currently being used. I think in this case, we did a lot of work to understand how the monitoring could be applied to historic structures and to buildings in the built environment. Needless to say, our understanding is still currently evolving. So with that, that's it. Thank you.
Well, good afternoon. I am the last speaker. Yay, we are almost there. ICCROM and the Nantucket Historical Association for pulling this together. I worked very closely with Marty in Geneva, and it was an honor to do that, and it was amazing to be able to, I think, pull this group of people together so quickly. And I think what we ended up seeing over the course of the last couple of days is that many people dropped everything that they were doing for this extremely important cause that we all share in many of the same ways. So, again, a real honor, and thank you, Marty, for everything that you've done. Of course, over the course of this year in Geneva, amazing to work with you. I think a round of applause for what you've been able to pull together in a very short amount of time is well deserved. So I also find this for myself an amazing opportunity, and for all of us to say how fortunate that we all are that this is taking place here on Nantucket, an island with such a unique and important history, one that's spread across the world as well. An island with such a rich mixture and number of historic buildings, and the fact that almost 50%, and I think that we need to think about that, almost 50% of its land is still preserved after all of the pressures of development that has been applied here. Truly something very special, I think, has happened here numerous times over the centuries, something I believe that we can all learn from. It is also important to remember that there are many similar communities across the United States and also across the world where cultural heritage is threatened in similar ways by the effects of global warming. I should have moved this the first time. I am an architectural conservator. I don't know why I'm talking about global warming, but I started my company over 35 years ago where we design architectural conservation programs and stabilization programs for historic buildings and sites. We also are a little bit unique as we have what I call sort of a conservation contracting arm where we can implement some of the programs that we design, and as a result, we've learned a lot as conservators. We've learned a lot from the craftspeople that we work with, and I think the craftspeople have learned a lot from us, so that the incorporation of the theory and the philosophy of historic preservation and building material conservation has really been incorporated across that bridge. So as I said, I'm not an expert in global warming and the effects that it has on cultural heritage sites. Whoops. But I am very experienced in analyzing a site, its buildings, and the materials that it's made up of, and through a number of steps developing responsible treatment options that require clearly defining the threats, prioritizing them, and finalizing treatment options that are tailored to meet the unique materials and specific threats at a given site. With that in mind, I have been wondering what to present here today. I am very comfortable when I have all the facts in front of me and I can make decisions based on those facts. When dealing with cultural heritage and irreplaceable objects, the mandate is to responsibly preserve them for future generations, to design and implement treatment options that are physically and aesthetically compatible. But one of the things I think that we've learned here, or that I've certainly learned here today over the last couple of days, is that we do not have all the answers. In fact, we actually have more questions, and that we cannot even define the long-term threats. That some cultural heritage, and also that some cultural heritage will be lost. I'm not used to standing before a group of people and making a presentation where I'm uncertain about these threats. In fact, I am very uncomfortable. But again, it's true. I mean, I've been thinking about it and listening to the presentations this morning, but also some of the more larger scale issues. The way I work is so based on a process, Frank, like you were saying, and to not have this information as part of the process is extremely difficult, to say the least. But when Marty and I and Geneva started to try to understand what we needed to begin to take action, what was missing, what we might do to try to find the answers quickly and put them into action rapidly, we began to understand that one of the most critical missing components was how and where to implement defined treatment options and protocols necessary to begin work. Some testing programs were already started, but were they necessary? Did we need the information that they were generating to begin our work? Even was the information that they were generating useful to begin work? Such programs can take years. Do we have the time? We agreed that one of the most important next steps was to bring a group of experts together who, no matter where they're from, are faced with similar challenges, and to use our time together to discuss how we might begin to develop a plan to take action. And I think that is definitely started, and I hope will continue. Maybe one part of this presentation, and maybe as part of my presentation, I can also help bring this a bit home for us here. Help to start the conversation about what approach we might take as architectural conservators and other associated professionals in such situations to bring our areas of expertise to defining the threats that global warming brings to a particular site, prioritizing them, and use our collective knowledge already developed and based on science about compatible treatment options for specific materials so that we can make quicker decisions, act faster, and potentially protect more cultural heritage. By bringing this information home, I think of how we might implement this work on an international level, national level, and local levels as well. I think if we can find pilot projects that are representative of many of the materials and threats, that we should start locally and work our way out and then back again, as many of us have said, always building our knowledge on previous work, both successes and failures. Thinking about what these pilot projects might be is very challenging. Let's just take Nantucket, for example. The threats on Main Street, at the Macy Warehouse, or here at the Pacific Club, where the basement is filled with water like this most of the year, is certainly very different than the threats that we might face along the cliff in Sconset, or in Nantucket, or at the old mill. Let's think about that for a moment. The variety and types of threats that exist based on exposure right here on this relatively small island are very complex. No one of them can be representative of the threat to cultural heritage on Nantucket. And I'll come back to that in a few minutes. But also, when I said that maybe I could bring this information home a bit more, I was also referring to how Nantucket has been for me personally, or how important it's been for me both personally and professionally. Because some of what I've experienced since I first worked here in 1982 for the Nantucket Historical Association is also applicable to why we are all here in this room. I hope you don't mind if I take a few minutes and tell you a little bit about my experience, while you, of course, keep considering the ideas about the complexities of the pilot projects here on Nantucket. So, my story is a bit different from the other participants, although connected in many ways as well. I'm very much connected to Nantucket, to the Nantucket Historical Association, and to Walter Beinecke Jr. Just out of undergraduate school, Walter made it possible for me to link my passions of history and craft together by connecting me with the Nantucket Historical Association, where as I said, I worked from 1982 to 1985 on the maintenance of their buildings. It was an amazing opportunity for me, one that changed the course of my life and helped me find a career that I could really dedicate my professional life to. Walter became a mentor to me in business and in the overall field of historic preservation, and I really feel very fortunate that I got to know him, and I got to know him pretty well. And I got to understand that he really had a very deep love and understanding of what makes Nantucket unique and so special to him, but also to all of us. He was ahead of his time and understood that there had to be a blend of preservation of the built environment with the natural environment if the essence of the island was to be preserved. He also understood that many similar historic communities across the United States were also threatened by the exponential growth of tourism and associated development. As a result, he hired architects, planners, environmental specialists to define what made Nantucket unique and ways to protect it. To be sure, he was also in this for profit as well. In fact, he coined the phrase preservation for profit, where he looked for ways to protect Nantucket, but also make sure that he and others could make a living here. As Marty said earlier, Walter also partnered with Blair Reeves and created what today is the longest continuous running summer program for historic preservation in the United States here in Nantucket, which continues to this day. I bring this up because Nantucket has been at the forefront of threats to cultural heritage and the environment for at least 70 years, if not longer. And there are very talented people here doing very important work. I think we have a great deal to learn from what has taken place here, what continues to take place here, and it is a perfect location for us to set goals for addressing the threats to cultural heritage that we face as a result of global warming, and see how what we learn at the Nantucket Historical Association, which I'll tell you about in a minute, can help inform building owners here and beyond. So for over the last 35 years, I've had the honor of working on some amazing sites across the United States and the world. Some sites that were always dealing with water management issues just based on the nature of their location, to those exposed to intense weather conditions and therefore accelerated weathering decay. So here I just show you we were very involved in working with the World Monuments Fund at 4 temple sites in Angkor. And, Siem Reap is an extremely flat location, so flat that when one river surges, another river backs up, and the whole culture is based on water movement. And I think, and how to adapt to that. One of the things that's actually even more incredible than the actual design and constructions of these temples was the water management system that was conceived and constructed and maintained. And it wasn't just for agriculture and growing crops. It was really for maintaining or controlling flooding as it happened often based on the location that I had described. So here's just one image of what happened when that whole Barai and canal system no maintenance had occurred, it didn't function any longer, and now with some slight rains during a rainy season, these sites are overrun. The earth is has a lot of clay in it, and not only monuments but trees also tend to lose strength and their connection to the ground and fall down. Excuse me. Another project also close to Angkor is the ancient city of Ayodhya. Also a similar situation there at the cross where 2 rivers come together, and they also constructed a whole series of canals and waterways and levees to control the massive water that came in. And this worked for hundreds, maybe 1,500 years. But again, over time, not kept up. And the fact that the amount of water that was being that the site was being exposed to was so high that even walls that were constructed to protect this site, because the rivers were rising, could not even withstand the pressures of the water. And in this particular case, that one of those walls were breached and the entire site was completely inundated. A little closer to home is a Horace Trombauer Indiana limestone building right here in Newport on Bellevue Avenue. And you can see its location is it gets battered by the wind, by the salt from the sea, and the amount of conditions that are specific to those locations, and salt efflorescence and the continuing salt efflorescence and freeze-thaw cycling were unique to the site, but not unique to buildings that find themselves in this area, like the breakers and others. So I look back on our work and realize that in some ways, we also were part of the problem. We designed conservation treatment programs to address current threats and those weather patterns that we were accustomed to, but in some cases overlooked the changes and that the future might bring, and how or if our work in the present would stand up to changes in the future. We could not even get many of our clients to think about maintenance programs or cyclical maintenance programs after we finished large-scale restorations. So as I said earlier, I am excited to report that we are beginning a new project with the Nantucket Historical Association to complete conservation management plans for each of their buildings in a sequential way, in a prioritized way, that will include a resilience evaluation to define the threats that each structure is exposed to from numerous perspectives, including the effects of global warming to that specific site. Coming back to the earlier thoughts about representative pilot projects and how we might use that information gained from them, maybe this is a way of taking that first step on a local level. Working with the Nantucket Historical Association and utilizing this data, we might find ways to inform other sites on Nantucket, and therefore might add to an understanding of how we take action at cultural heritage sites on a local, national, and maybe even an international level. Thank you very much for your attention.
I'm going to ask the Thank you, gentlemen. Yeah, there are three of you. Yes. So, thank you for some case studies for the United States. We talked internationally this morning and bringing it back home to Nantucket. Happy to open up to questions on the floor, but I will maybe start with what I asked the speakers this morning. You know, we've just spent 2 days in a workshop, and Geneva and I are getting ready to share some of the preliminary results of that. But what do you think are your real takeaways this week?
Can you hear? Yeah, I should have paid more attention. Takeaways. Feel free to go while I'm thinking, but
Attention. Takeaways. I think, Johanna, what you're saying, I think one of the most important takeaways to me is that we are sharing the same threats, we are sharing the same planets, we are connected across oceans, and I think the closer we get, the more we share our information, the further we'll get, the faster we'll get there, and maybe we'll come up with better solutions. Another takeaway from Stefan is that I'm much more worried today than I was when I came here. It's not just because of you, but I think, listening to everybody, and as Frank was saying, it's worse than we think. It is worse than we think, and I tend not to think about it sometimes, but it is very scary. And when we talk to our colleagues at the Park Service, or even projects here on Nantucket, some things are going to have to get lost. And what are those things, and how do we decide what they are? Where do we waste our resources? Where do we not? I mean, those are all important questions to be asking, and it's important not to waste too much time thinking about them.
I think a takeaway for me is in the last two meetings over the days that we've had of discussions with colleagues is that it's a very complicated series of things to address. It's, as I was saying, it's not just about resiliency. It's not just about looking at carbon reductions or building resiliency. It's about all these things simultaneously. And that's a huge task, especially when our targets are changing every day, and it makes it seem daunting to keep up with it. But we have to try. So that's one of the big takeaways for me.
okay, I'm ready. So, as a teacher, as an instructor, I think a lot about the relevance of what we're doing, and I've been teaching conservation for over 35 years, and only a few years ago, I'm kind of late as a convert to making climate change front and center in the teaching. I think universities actually have a major role to play in this. So I've been thinking a lot about how do we get to the two issues of our day, which are the climate crisis and social equity, into our agenda. And we talk a lot about it, as you can imagine, a lot at the university. But to see the action play forward is sometimes a slower process and frustrating. I would say the takeaway from here, though, is that we're all more or less of a common mind here in terms of we have common interests, and we assume we all believe the climate crisis is real, and we have to act. But what I would say, and we all have to do it from wherever we are at this moment. I mean, you can easily get overwhelmed with the immensity of the implications of what will happen if we don't. And so I don't want to go down that path because it leads nowhere. So the only thing we can do is start where we are. And I would say that what I have to come back, and what we know, and what I would have to come back to is that I think we have to advocate in whatever way is appropriate and useful and possible from our position. Otherwise, it becomes overwhelming. So I would say, in the scheme of things, people versus built heritage, it's people. But I don't really work in the realm of sociology or social welfare. I work with buildings. So I have to figure out how I can connect that to the climate crisis. And there are many ways, as we've heard. I mean, just the incredible squandering of resources that we have been doing, at least since the Industrial Revolution, if not way before. So I have to think, what can I do? What can we do? What can the folks I teach do? How are we going to change that next generation? So my takeaway is that we have to do more of this, because only in numbers can we begin to organize and then get the word out. And I actually think, look, historic preservation began academically in the 60s when there was really a public reaction to the failure of planners and architects in shaping our cities. And the same thing is happening now, and we need to act as a concerted whole on a much more global, environmental, and integrated way, not keeping nature and culture apart, but bringing them together. And education is one way to do it.
To kind of follow that thread about the integration of the natural and the cultural, I think the Climate Science and Disaster Response Program that Geneva and I have been standing up, as she says, I think one of the things that excited us both is that we're really embedded within the Climate Change Response Program for the National Park Service, which is up till now has really been natural resources. And so it has to be that integrated approach. And I think that Nantucket, I'll ask you the same question I did this morning. I think this is your first time here, Frank. It's been a while for you, Kyle. I know you're here all the time, Glenn. But I think that's where better can you think of another National Historic Landmark District that has 50% of its open space preserved and so much good research. We heard from the two good doctors over there the other day. So much good research being done. I mean, Nantucket is sort of leading the way, right, for the integrated approach. I don't know. What are your thoughts? What were your impressions of Nantucket? Your microphone.
Yeah, no,
you need to think.
My brain has to move my mouth, and then I'll. Well, I mean, I was overwhelmed at the incredible beauty, and I must say, I was very impressed at that 50% statistic. That's really important. Extremely important. Carrying capacity is extremely important. Integration is no question. There's no question. Integration is necessary. I think you have a laboratory here, and I think, as Glenn was mentioning, I mean, you should treat every project as an opportunity to explore what has not been explored yet, and that means a more integrated way to solve a problem. And the problem is complicated, so it's going to need multiple disciplinary efforts, as well as others, not necessarily represented by a discipline. And there's something manageable in living, I think, and I don't live on an island, but there's something manageable about living on an island. You know, you kind of have boundaries. You can think about the problem in a bound way. Mentally, to me, that's really good. Psychologically.
Kyle, you have any thoughts about Nantucket?
I think one of the biggest impressions, positive impressions that I had was when we took the tour on Monday, and we walked around, looked at the programs that there was a tremendous amount of work done on coastal erosion. And I was just, I found that to be a very learning experience. I mean, I came to Nantucket, expecting to participate in discussions and to provide input, and here I was actually learning so much more. And I thought that was an incredible takeaway. And I wanted to learn more and to come back and to be part of the work that's going on here. So I felt that it was very, a moment of being impassioned. So thank you for that.
Glenn, you have the long view about Nantucket. I know you did, but you got to say it again. Microphone.
I do, and I think that, like you're saying, it is an incredible laboratory, and I think one of the things that we've been talking about as a group is like how do we find a laboratory? How do we identify a space or specific spaces within a location that are representative of that laboratory, and then how do we generate the data in a rapid way and based on our knowledge, our vast knowledge of building material conservation and the methods and materials that we already know work in many different situations, how can we start applying those? And again, as I said, I think the long view for me here is learning from all the work that's been done on the environment and coordinating that with the buildings, and maybe even using a lot of that data to inform what we might be doing. And I think that's another big thing. It's like there's a lot of data out there, and finding the right people who have looked at things in a similar way that have already generated data and bringing those people onto the team is another way of sort of speeding this process up.
We did in the meeting this week, we did talk a lot about inventory and monitoring and how our natural resource folks, and that's both within and outside the Park Service, have been doing that a little longer, right? And what we can learn from that. We'd started out initially, part of the impetus for this was scientific testing, controlled testing in a laboratory, but I think that, is it fair to say that the discussion this week was really migrating as much to in situ experimentation in the field, the RAD concept, as you noted, and to begin to use our cultural resources in that way? I don't know if you want to say anything, Frank.
So, I mean, you don't want to waste time, but you don't also want to make false starts. So I think you can't just, enthusiasm won't necessarily get you to the right answer. So I think it would be really important to set the table before you eat. I think you've really got to think about this carefully. Best time spent is planning, and then execution is only as good as the planning. I would say that, yeah, you do. From what I heard, what you all presented on the coastline remediation and thinking about not just the solution now or the next 5 years, but the long term, I think that's the key. So that and it's one of conservation's principal tenets, which is retreatability, to be able to recover from, retreat from what you've done and then go, further. We used to call it reversibility, but that's out of the picture, certainly for climate change. So, so I think, again, wouldn't you like to have the island moniker of beautiful and sustainable? You have the ability to actually bring these things together, nature and culture, in a way that can be activated by climate change. See it as a catalyst, or the climate crisis. See it as a catalyst, and then really show the world some demonstrable projects that have short and long-term results. I hope we're around to see those long-term results, but you could do it here. You certainly don't lack the means. So, serious.
Yeah.
So having had these conversations, and they're similar to what we were talking about with people from the Park Service, is that finding ways to then connect that information on a national scale, and then sharing that information, as we say, up and down, I think is another option to be, or another important piece to be thinking about.
I don't know,
Marty?
are there
Marty?
comments? Oh, yeah. Go
Can
ahead.
I
Oh, sorry.
add to that?
Yeah, absolutely.
The other thing that this wonderful laboratory has is wonderful people, because I keep saying it's people-centered, and everything that we do has to work for the people. So having the people involved in all of that experimentation right from the beginning, that's amazing, and that's really valuable.
Trust me, I've been here a while. Nantucketers pay attention. They're pretty engaged in everything that goes on, right? Absolutely. Are there other comments or questions from the audience? Kind of open it up. Yep.
I think one thing which really needs to be demonstrated is that how building conservation projects can be related to planning. Because somewhere, if we have to make a change, somewhere the planning interventions have to somehow correlate with what we do at the building level. So if we can have demonstration of some of that linkages through initiatives, I think that would be very useful, because just working at buildings sometimes will not address the issue. It has to be connected to the larger planning level.
Yeah, we talked a lot about scale, right? And the different scales that this needs to happen at, our actions, right, to address the climate crisis. Any other questions or comments? Oh, I got one here.
Thank you. Maybe a two-part question. We do have a lot of conservation land in Nantucket, which is awesome. Most of it is on the high ground. How long before we plan to move the town up to the high ground? And in the meantime, what can we do to protect the candle factory here?
I'm not going to touch that one. Let's start with the candle. Let's start with the candle factory. Glenn, would you like to say something about the candle factory and the work with the NHA? Yeah.
That's part of the program. I think when Niles and Ed and I and others were talking about what are the highest priority structures and the threats that their buildings are facing, certainly the candle factory is one of them, regarding how low it is and the flooding that's been happening here and the projections that we are learning from Marty's work. Also the continual flooding that happens here and the complexity of the areas out back and the sewer system backing up and all of that. So it's an extremely complex project, and getting many people involved in it is something that's is necessary. And I think, we haven't done, maybe the larger we, and maybe some people have, but when doing a conservation management plan and involving a environmental assessment and the effects of the environment on the structure based on the site and its exposure is something relatively new. I think what's happening here at the Whaling Museum in the back is going to be extremely challenging. But it's going to be a prioritized process of going through each of the buildings. Your other question before, I might as well. Yeah. If you're running to the high ground here, you probably don't have much time, so I'm not sure it's worth it.
Yeah.
I would, forgive me if this exists, but I think, again, I know nothing about previous studies or analysis of the island, but it struck me, something Robin said, if you haven't taken an historical ecological look at the evolution of your building fabric and your town planning, that would be a very good thing to do, because you would see the local knowledge embedded in the responses to what was the climate normal. Then you could, at least from a building perspective, work within those traditions and then elevate them, change them, modify them, whatever you need to do. That would be the place to start. But if it hasn't been done, I certainly think, I was really struck again about the historic, remember, I know nothing about ecology, but even though I have a landscape department that has ecologists right next door to me, problem. I was struck at you were talking about the landscape and the ecology on our shore walk in time past and present, where it had been and look what happened to it. And it wasn't always a wise change. So again, you were going back you were striving to go back to a status that was more sustainable. And I think you could do the same in terms of the town. And again, I'm sure there have been studies done, but an ecological history and projections forward would be very interesting. I know a colleague, Matthias Bau, has just done this for the island of Manhattan, and it's been accepted now, and they're going forward with it. And that's daunting when you think about the real estate. But that would be a suggestion.
I may jump in here. I didn't expect to, but maybe I will. So for my last 3 years as director of the Preservation Institute Nantucket, University of Florida's program, we really focused on, it was a multi-year study on resilience. We started with the digital documentation of downtown and the image that you see, that, modeling in 3 dimensions, sea level rise, based on NOAA projections and a lot of other data. That was the first steps to understand the vulnerabilities, right? And then we began to, we took the Washington Street area and the creeks part of town, and over 2 years, what we really developed was a managed retreat plan, essentially, which, I thought I better get a new job and get off the island because they're going to kick me off the island when, people saw that their homes would no longer be there. But one thing that, what you said about as you go to high ground and you have all of this, you're actually going to be potentially trading off. You might end up developing in areas that are protected, and you're going to be having new areas that are natural resource, natural heritage areas that then would be protected. Do you see what I'm saying? It's not a either or.
Yeah.
As Washington Street in that area reverts back to, which it will, to being a saltwater marsh, right, like it was originally, then maybe the Nantucket Conservation Foundation or Linda Loring now protects it. You see, but that's also going to require policy and a lot of, it's going to be complicated, but it could happen. Go ahead.
Exactly what I was thinking, that it's always useful to make a virtue of a necessity. So the bird life and so, with the marshes increasing, becomes the new tourist attraction rather than the heights. So there's a swap. And I think that's same here for the candle factory.
Well, and Claire Martin's here from Remain Nantucket. They're on their 3rd iteration of the Envision Resilience Challenge, and I co-chaired the first one here on Nantucket. If you haven't seen it, it's an amazing website, a really remarkable initiative, 5 universities coming together. One of them was just that. There was a bird sanctuary in the Washington Street. I was working in Florida. Let's just say your approach here in Massachusetts to conserving natural resources is a little different than Florida's. And, with the help of Kim Rose sitting in the audience, we looked a lot at the policy and the protections, for example, of saltwater marsh. But that's for existing, right? Once it's a marsh, it's there. Policy doesn't address what happens when you're creating. Do you see what I'm saying? So there's a lot of work to be done at a lot of different levels, from that top down and bottom up. Oh, Jen.
Thank you. Because it's my conservation land you'd be moving to, I thought I should weigh in a little bit. But, as we're talking, I keep looking at this picture that's behind you guys and thinking that, yes, there are places where managed retreat might make sense. Washington Street, thinking, can we don't migrate everything, but we bring some natural areas into parts of it. But then tying that nature and culture piece together, when I think about where we are right now and I think about parts of downtown, that would be a lot to migrate and walk away from and still keep that historic culture in place. So how do we think about inviting the water in? And I know we talk about that a lot. How do we think about creative ways to take what's going to happen there and still keep the culture in place? How do we pull pieces of nature in to where we already have our downtown that can help us mitigate it? And I don't have the answers, but I think those are the partnerships and connections we need to start to look to, is how we can start thinking that way and actually starting to adapt to the downtown now, because that's coming sooner than we think. And we're going to have to start working on that now if we're going to be able to keep that culture piece in place.
Me again, please.
Sorry, Robin.
Sorry, but that just sparked something, because I was looking at the map and thinking how much it reminded me of the map of Venice. Venice does quite well in that regard.
And can I also say the National Park Service and 2 of the authors, Jenny Parker, Jen Eggleston are here. There was another Jen involved. The flood guidelines for rehabilitating historic buildings, which quite frankly, those guidelines are excellent. And they're not just for historic, they're for all buildings. And I think the Candle Factory is a great potential case study, right? And model for both could be wet proofing or dry proofing. But they're absolutely, and there are already changes that Niles walked us through there and explained, he and Ed, some of the things that are happening. And I think that's why it's so important that the NHA hosted this, because just like, Linda Loring or NCF, your leaders in that area, it's really the NHA who's the leader in doing, adapting our cultural heritage to climate change.
If science is the headlights of the car driving down the darkened highway, I would make a pitch to say design is the way you're going to get this realized. So you've got to bring designers into the equation here. I teach in a design school, and the very best things that happen, as Marty knows, is when actually everybody's all together solving the problem. But it is design, it is architects, landscape architects and planners who actually give form to the science, give form to the ecology, to the materials science, to the climatology effects. So don't forget those people.
Well, and again, the Envision Resilience Challenge is doing just that. Rather than, there's so much that you can get mired down into, and among the many great outcomes was that it was looking at 2,100, 5 universities. And I've done a lot of good things in my academic career, but this was probably one of the highlights. To have 5 universities come together. It was originally proposed as a competition, and they said, we don't want to compete, we want to work together. And it was landscape architects and architects across, not only within a university, but across 5 universities. So I encourage all of you to take a look at their website and some of those outcomes.
Yeah, I have one remark to this. I'm impressed by this discussion about different streets and different buildings and different salt water marshes and other areas on Nantucket. Just as I'm a scientist and a man of numbers, I just want to draw the attention back to the world and the global perspective. So we said this morning that rising seawater levels is one aspect, but not the most dangerous one. There's way more dangerous ones. If you look at the water level rise, we have 20% of UNESCO World Heritage being threatened to be underwater. 1,150 World Heritage Sites, 24 in the United States. So you see, it's not like a big number, but they're all across the world. And if you look at this perspective, that 20% of these World Heritage Sites, this is our profession. We work on heritage. And I think at the end of the day, a candle factory is as much heritage as another which has an outstanding universal value. This is our profession. So we have thousands and thousands of heritage sites. Just the World Heritage Sites, 1,154, 20% underwater, just to keep these numbers in mind, under the 3 Kelvin scenario.
Johanna.
I just wanted to remind you, don't forget to lobby on the political level. Try to include cultural heritage in your national adaptation plan. Then you will have the visibility all over your country and also on international level. So we need to do the implementation, but don't forget that it's really important to do also this political lobbying. And I think you here in Nantucket, you are not so far away from Washington. Maybe your president or the Minister of Environment comes more often here. So don't forget this lobbying.
Well, and I don't know if you're comfortable sharing what you did with me this morning, that you heard from a colleague. Do you want to share with?
No, you can say it.
No, you say it.
Yeah, I received this morning an email from my colleagues from the European Commission, and they wanted to know the program, what we are doing here, because it has now grabbed the attention of the commissioner, the cabinet of the Commissioner for Culture, Research and Youth. And you see, this kind of little competition is always good to make people move.
Any other questions or comments? I will say to do an international gathering on Nantucket is also meaningful because my very first summer here, I actually, the caretaker of the University of Florida's properties and we actually went and had a drink and we're going over things that need to be done. And I actually heard two women next to me say, one of them was like, well, what are you doing tomorrow? She's like, I'm going to America. And I was like, did I hear that right? And so Nantucket has always been sort of fiercely independent, right, in a good way. Well, unless there's any further questions or comments, I think what we'll do, we'll get a round of applause for these three. We're a little bit ahead of schedule, but, you know, it'll be close enough to 5 o'clock when you're ready for that wine, right? I'll bring Geneva right up, and we're going to wrap this up. Thank you. So what we're presenting here, the caveat is it's very preliminary. We literally pulled this together in our wrap-up session yesterday afternoon, less than 24 hours ago. And Geneva and I, let's just say we're sleep deprived. So I hope that it makes sense and there's no typos in this PowerPoint. So what we've done over the last 2 days, and I don't think we had 7 outside experts who you've heard from, paired with 7 colleagues, experts from across the National Park Service. They represented both, architecture and archaeology, building trades. And so we did do an amazing tour the very first day. Again, we were joined by representatives from town, as well as some of your local natural heritage foundations or organizations. So that was a great way of really immersing you in Nantucket and seeing the kind of microcosm, a lot of the things that are happening here, right, are happening globally. And then we locked them in a room. As I said this morning, they gave us very generous the portrait gallery, and it was you had to do something important because you had Nantucket's history staring at you the entire time. That first morning session was a more broad session looking at, and we were moving toward what we really called a strategic framework or strategy. And that really was a broad conversation looking at all of the challenges. And then the next 2 sessions, the afternoon, the second morning, did a deep dive into the southwestern United States, an overview of that region, and then the southeastern, and 2 remarkable case studies, one of which you saw here today. Our colleague, Kelly Clark, who's done amazing work at Dry Tortugas or Fort Jefferson, which if you're familiar, right off the coast of Key West, is definitely one of the National Park Service's primary poster children for climate change, specifically coastal hazards and resilience. So, and then again, we all came, we took notes, we had a great rapporteur, we brainstormed, we talked, we did laugh. This is a great, very collegial, both in general and at each other at moments. So from that, again, we did a quick content analysis of our notes, everything that had happened, and Geneva's going to present where we stand. I will say, for those of you who we are moving toward, if you weren't here this morning, what we're calling, often when these international gatherings happen, they do some sort of declaration. It's short. What are the criteria? It's short and vague. That's and courageous. Like Napoleon, I think that's what we said. Short and vague, maybe courageous. Crazy a little bit. But so with that, over to you, Geneva.
Thank you. And thank you again, all of you, for your time and attention today and all the wonderful work of our participants in this workshop and symposium. It's been a phenomenal experience. So when we were getting started, we've had a lot of thoughts about how we connect cultural heritage in our minds, in our actions, in our policies, in our decisions to the climate crisis. And really one of the big outcomes that emerged throughout this session and throughout our prep for it was that cultural heritage can be a bridge between climate science and people. Our stories, our places, the things that make us who we are, where we have come from, where we're going. And all of that is incredibly overwhelming and gives us a huge amount of work to do. But as we were preparing, there was this incredible quote, Johanna, from your report, which has been sort of structuring my thinking throughout this session, and that is that research programs are the indispensable drivers of implementation. And so for us at the Park Service, where we have these our nation's most wonderful resources, and we are going to be the stewards for the benefit and enjoyment of the American people, we need that implementation. We need those actions. And so in trying to create that research program, or at least the initial structure of it, these are the elements that we have identified. So we have 4 broad categories where we can be targeting the variety of actions the Park Service is already incorporating, the great research that our colleagues have described, and the connections to these broader local, national, international collaborations that we're standing up. And that is understanding the resources that we're working with, our cultural heritage resources, our natural heritage resources, and the interactions between the two, our intangible heritage, and how we're keeping track of them through inventory and monitoring. It's standing up those pilot projects, as we said, to inform from the bottom up, and also then to understand how our top-down policies are actually working. It's providing practical guidance, and it's really confronting and identifying and working to come up with strategies for our challenges. So with that in mind, obviously I'm not going to go through all of these because that's way too much, and I do invite my colleagues at the end to tell me the things that I missed in my brief synthesis. But really what we're looking at first is structuring those collaborations just like this today, finding those common platforms, just as the EU has identified, as we've talked about at length, to bring in many different data sets. And by data, of course, I mean climate data, but I also mean traditional knowledge, local knowledge, the observations that are just so integral to our understanding of places. It's coming up with inventory and monitoring programs that can also be really accelerated. And by that, we don't have time. We are in a crisis mode. If anything, Stefan, you've been my rock all week because you are on target. We have to move and move now. And so to do that, what I am specifically looking at is how do we incorporate expansion of our citizen science work, of our community partnerships, and how do we drill down to rapid, targeted, and the minimum necessary information to allow us to move forward and then learn from our mistakes and be replicable, be intentional, make decisions, and then try to learn from them as much as we can. As we move, though, if we have that structure to then help set up our pilot projects, the idea of parks, of specific locations as laboratories. We've heard a lot about good work that's being done in situ, which is the real place that we can understand not only the climate exposures and the threats that are imposed, but also how they're being managed right now. The capacity that is there on the ground to be able to implement any of these actions, that's the really critical element of having these site and place-specific projects. With that also, it's really understanding our values-based approach and understanding also that values shift over time. The things that are highly meaningful or highly weighted today may be very different at various time horizons. And so trying to understand how we can incorporate a bunch of stakeholders, viewpoints, things that are not commonly captured, and also keep our eyes out for everything that we're missing as we're trying to create replicable and scalable pilots. Then guidance, because we, of course, as the Park Service, we are inward facing, we are outward facing, and we have this incredible collaborative opportunities. And so we need to be capturing those things in the form of real practical guidance that can be actionable. It's one of my favorite words that makes Marty crazy, because that's always my benchmark for what we do. And so, what we're looking at is not only trying to create these things, incorporating all of those different considerations and knowledge sets, but also how we can, again, work towards co-management and be providing things that make just as much sense to a cultural resource manager at a small park as they do to a community manager, as they do to a private historic homeowner, as they do to someone who is just trying to figure out how to cope with their own story and their own places and their own heritage that is under threat from climate change. There's, of course, any number of considerations into that guidance, including figuring out how to be intentional with our cost expenditures, both in terms of financial resources, our time, our effort, how we're going to actually understand what we're doing and why we're doing it. Having those feedback loops built in so that we have some latitude to make mistakes, but not many, right? To keep us really moving forward, and then continue trying to have that top-down, bottom-up approach and meet somewhere in the middle that makes sense. And then understanding our challenges, our opportunities. We've heard a lot about urgency. We've heard a lot about time, our limited capacity. But it's really more than that, too. What we've identified here is a tremendous opportunity to collaborate, to break the silos, to get together, as I hope we've done over the last few days, having the right people, the right time, the right place to develop these programs, to make some sense out of all of this work. And my hope is that, as we're structuring this framework to move forward, and we can come together with the various projects that are going on in the public sphere, in the private sphere, in the international sphere, we can really continue learning from each other and developing our ways forward, because that's the only choice we have. So thank you all so much. Thank you for your time and attention. That is what we are moving forward with as we create our declaration, our Nantucket Declaration of Cultural Heritage and the Climate Crisis. Thank you.
Well, as you can tell, we're a little bit ahead of schedule. Apparently, the catering's being set up right now, so just hang tight. I'm sure our colleagues, both in the National Park Service, as well as our colleagues from Europe and the United States, will be happy to answer any questions or have one-on-one conversations. So thank you very much.